What's up, Amog?
So,
Are you still at school? Or you're off the bus? It's kind of early for you, yeah?
it's 3 o'clock. I'm on the bus.
Oh, you're on the bus right now. Did they actually get you a seat this time, or are you still sitting like in the middle?
I came early on the bus today, so I'm actually on the seat.
Wow.
That's dope.
I love having a seat, dude. Nice. Oh wow, we're getting a little live preview here. Let's see the live preview of the bus, dude.
Yeah.
Hello.
What's up, Ethan?
Oh my god.
Wow. Damn, look at
I think
this.
this is a bus.
Dude, this looks like this was recorded in like 1972 or something, dude. Like, what is the fucking video quality on this thing, dude?
I don't know. I'm Nitro too.
Yeah, bro, what is that's trash, dude. Excuse me. Okay. All right, cool. Good. Well, get home safely, Amog, please, you know. What's going on, Falcon? Getting ready for your stats test, yeah? You got a stats test coming up?
Nato, how are you doing?
Yeah, what's up? I'm chilling. I'm a little tired, but I'm chilling. I'm here.
Okay, man.
Yeah. Oh man, I wish this coffee wasn't bad. I made this coffee like 2 days ago. I can't drink it. What's up, Cosmic? Cosmic's here too. Was something Cosmic out with some was it some physics last time, or it was like engineering physics, I think is what it was. Oh, let me make sure my my Fortnite's updated, right? There's a new Fortnite season that came out?
Yes, it's kind of like it's like the season has already happened. It's like going from season 5 to maybe season 9.
Yeah,
It
but
keeps going out every week.
they keep changing it all the time, right?
Mm-hmm.
Where's my library? Oh, it says no. I don't want it to actually run Fortnite. No, don't do that. Don't actually run Fortnite. I will make you suffer tonight. I have all my homework done.
That's dope.
It's okay. I'm down to suffer. I'm down for some suffering, dude.
Hello.
Yo, what's up, Hypatia? Tired?
So tired.
I know. I feel you.
Well,
I feel you. I'm tired too.
uh,
It's like I need
for
Fortnite.
of being academics.
Yeah, right, dude. Dude,
Uh,
wait till you get to grad school.
I'm kinda already in the grad school.
Right? Yeah, you basically are in grad school.
Yeah.
You're TAing. You're basically being
I'm almost done with grad school because I'm almost done with the paper. Like,
Yeah.
I have three propositions. I've done 2 of them.
Okay. Wow. One sec. I gotta.
Well,
One sec.
whatever.
This is. I accidentally launched Fortnite because the
What?
kids told me. I accidentally launched Fortnite because the kids told me to see if it was updated. One sec. I gotta close it. It's gonna start breaking
I was
my
thinking
stuff.
next, when I finish that, I can show you my paper about weird things.
Okay. I like papers about weird things.
It's,
Yeah, send them
it's
to me.
What?
Yeah, send them to me. Send them to me. I'd like to see it. I think it'd be cool.
You are lagging, I think.
I know. It's because Fortnite accidentally opened. It should be closed now.
Oh, okay.
There we go.
Oh.
Should be better. Yeah, send me your paper. Send me your paper when you have it. I'd like to read it.
Do you know about motives, zeta functions, liftings of invariants, stuff like that?
Not quite. Wait, zeta functions? Zeta functions? Let's look up some zeta functions.
It's a particular kind of zeta function. It's the analog of the infamous Riemann zeta.
Yeah,
over
the Riemann
finite
zeta
field.
function. This is Noyce knows about the Riemann zeta function.
I should teach Noise how to do those kind of things someday.
You
and
should. I
that's
feel like Noise would appreciate it. Also, your audio quality is like super great today, Hypatia. What did you change?
Yeah, it's my phone, not my computer. So
Oh.
the phone costs a lot. So
The phone has the best audio. Yeah, we got to get you a better headset. Did your parents buy you a new laptop yet?
they agreed to it
Oh,
because they
nice.
got they got it. But my school also offered a compensation if I keep teaching next semester.
Yeah. I told you, like the school will pay for you. They'll pay for things like these because you need these to teach. Like they'll pay for them.
I mean, I don't know. I mean, there are stuffs that are going well, but there are stuffs that are going not well.
That's how life works. There's a lot of ups, a lot of downs. I agree. It happens a lot. But we got to keep going. You know, that's the important thing. It's just like keep pushing through it.
Either way, today I'm back home, so I'm going to lie down, and if you have any question, I will be here to answer.
I appreciate that. Appreciate that, Hypatia. You're the best. Relax. Enjoy yourself. You know. All right. What's a Moog saying? After the grade, my essay grade came out. Oh well, it depends. Like, yeah, it depends on like what percentage your grades are worth, right? Yeah. Cosmic said no. Cosmic, no C plus, no C plus. Inside Tennessee. That's cool. I have family that used to live in Chattanooga. I used to go to Chattanooga a lot. At least she gives 50% for trying. Yeah, that's a W. Okay, cool. Let's start the stream off. We got some good questions. All right, welcome everyone to Office Hours. My name is Dr. Gold's Actual Education, sorry. Stream that helps you with math homework, science homework, all types of fun stuff. What was I doing last time? Ooh, we're doing a lot of multiplication stuff. Where is... let's see. Oh, good. Ethan, I think, has some... Wait, Ethan, where'd you post your question? Oh, there's your question. Cool, here we go. Nice, okay. Let's see what you need help with. The volume of a penny. The volume of a penny. Okay. Yeah, that's okay. We'll help you with both. And then this
The
one.
thing, let me explain something.
What's
Let
up?
me explain something real quick.
Explain it.
Basically, do you know what are experimental errors in physics?
Yeah. Experimental error is
Basically-
like things that are wrong because we're humans, basically.
Yeah, we can't accurately get the exact answer.
No. There's always going to be a little bit off.
So, hold on. Could you go to the first one that I sent in, the other one?
Is this the first one?
Yeah, look at the right side.
Okay. What about it? Oh, you want me to do that question?
Yeah, because I it's like something I have to submit in by tonight.
Okay, well then let's help you out with it.
I
So
yeah,
read
but seriously,
the...
it's like
Sorry, go on. What's it, Ethan?
see, I'm not getting the experimental error thing, okay?
Okay.
Like some people would say, like in some experiments, people would say we measured wrong, but it's not really considered an experimental error.
Okay.
It's like an experimental error is something that happens in an experiment that could be different from what other people get.
Of course.
So it's like, for example, like taking a bunch of plants and putting them outside, like on a table near a window.
Uh-huh.
There's no way that all the plants will get the exact same sunlight and water, which that is an experimental error.
Exactly.
Those are two experimental. That's what it is, but I'm really not identifying a pattern.
Okay. So here it says, you're trying to find the volume of a rock is measured by water displacement. Some water is placed in a cylinder and recorded. A rock is then placed in that cylinder. The volume is measured. The two measurements are subtracted to obtain the volume of the rock. Okay. And you want to know 3 potential sources of error? And like what would happen because of that error? Yeah?
A tree, right? And discuss what the effects will be on the results.
Okay, cool.
I think, yeah.
Okay, the first thing I would think about is what's called like reading the meniscus. Have you heard of that? Reading the meniscus?
No.
Okay. So, whenever you have something in a graduated cylinder, right, and you try to read what the level is, Ethan, right? say you have something like this, right? And we got like a bunch of like, well, these aren't really straight. One sec. There we go. Bunch of readings, right? Okay. What happens when we read liquid, okay, is that the liquid will kind of do something like this. It'll look kind of like a bubble. I mean, this is exaggerated. I'm exaggerating this, but that's kind of what it'll look like. Have you noticed that before? That like when you try to read the water line within like a graduated cylinder, it isn't exactly a straight line.
No,
Right.
I mean, I have experience with it, but
Yeah.
it's not a straight line.
Yeah. So it's exactly. So yeah, they're all saying good things here. So what we this right here, this like this dip, this is called like the meniscus, is what it is. And so when you're reading,
What is the meniscus?
the meniscus is like the bottom of this. It's the bottom of the bubble, I guess, is what it is.
No,
Here.
it's the minimum for a parabola.
The minimum, right? Yeah, exactly. So here, like meniscus in graduated cylinder. Like, here we go. Do you see this? Do you see this, Ethan? One second, let me open this image in a new window. Where's open image?
See what again? I see what?
Do you see this? Do you see how there's like kind of like a bubble?
It's like you really have to wait quite some time for it to be straightened out.
Yeah, but it's not going to be straight. It's always going to be like this. What's up, Tika? Yeah, this is due to what's called is this called adhesion? I think this is called adhesion, is what it is. There's a property of
Adhesion.
water. It is adhesion. Yeah, it's not cohesion, right?
Yeah,
It's
the water
adhesion.
likes- yeah, because the water likes to not stick. It wants to
Yes.
stick to the side.
Exactly. Yeah. So it actually it's a cool thing. There's a thing called the capillary effect where this happens, where water wants to stick to the edge of this glass here, Ethan, and so further away from the edge, the water kind of sinks a little bit. Okay. And that creates like a curve. All right. So when you're measuring the water level within a graduated cylinder, you have to do this by eye, right?
Mm-hmm.
And so when you do it, you want to make sure not to measure it like at the top level. You want to measure it at the bottom, and that's called the meniscus. So a mistake that people will sometimes make is they will read the water level right here, right? They'll read it right here, when in reality they should be reading it down here. This is the water level. So this is wrong, but this one down here is correct. Yeah. Me realizing I did my 3-hour lab wrong. Uh-oh, Cosmic. Yes. So that's one way that the measurement, that's some experimental error that could happen, Ethan. We say that you could be not measuring the meniscus correctly. Does that make
I
sense?
don't know if the teacher will understand that.
They will.
I don't know if the teacher will want that because
They'll
wait,
understand.
hold on, we haven't even gotten to that.
No, but it's a very common thing with measuring water levels in graduated cylinders. Your teacher will know this.
Well then,
And you can tell them
could
that
you go
like
back to the other-
you can tell them like you got help from, someone online. They'll be like, "Oh, that's cool."
But what did they say that you shouldn't trust people online?
Okay, you can trust me though. It's all right.
Yeah, okay.
But yeah.
So anyways, yeah, could I see the image closely?
Which one? This one?
No, not that one, the other one that you were just on.
This one right here?
Yeah, look at those tubes. There's no meniscus on them.
Right, because this is a cartoon. But in real life, Ethan, there would be a dip. There's going to be a dip.
Okay.
So, yeah, there will be a dip like that in real life. So, I mean, that's what they're saying. They're saying, like, if you were to... We're not saying from the cartoon. We're saying, in real life what happens. In real life, there would be a meniscus, and that would cause it to be kind of difficult.
So how should I say that for the first one?
I would say reading the meniscus incorrectly.
Could you get it to me when you finish both of them so that I could type them down?
Yeah, I'm writing them out right here. Is that okay? Is that how you like
Okay.
it? Is that okay?
But what I'm meaning is like when you sometimes save questions for people and then you post them as like a PDF, you could do something like that.
Yes, yeah. No, I'll send you the PDF. Yeah, that's fine. Yeah, you're good. Yeah. So reading meniscus incorrectly, and that would cause an overestimate, or, well, most likely an overestimate of the volume. Right? I'm not using a mouse. I'm using a tablet. A Moog. I have a tablet. He's actually stage 3 psychopathic.
Dang.
Dang, a Moog, dude. That's too funny. Yeah, okay, so that's one way. And actually, Amog had some other good ones. I liked Amog's. Amog's was the rock has water on top of it when you take it out. I like that. That's actually a good one. That's a good one.
So put that down then. You could put that down. Or
Yeah, I would
you
say
could
that.
also
I would say that
experiment
like I would say that not once a rock is placed and the volume is measured. Well, yeah, but Amog, what happens is we record it without any water at the beginning. We don't record the water line after we've taken it out, so you wouldn't actually lose any water, right? Like losing water afterwards doesn't really matter. But here's what we could say. We could say that it's funny, like they want 3 ways that this could be wrong. Like, excuse me. Okay. Okay, here we go. You're in a very hot room. I'm trying to think of just like something. You're in a very hot room, and
Wait, I don't think that's valid here.
no, it's okay. You just say, let's say there's no air conditioning, and we say that some of the water evaporates. In the tube evaporates.
Okay, I don't know if the teacher will accept this.
Well, just try it.
No, wait, but then what if he minus points from me?
Okay, well then whatever. Like, you're asking me to come up with
So
ideas.
you're really not gonna get.
These are my ideas.
Okay, man.
Okay. And some of the water evaporates.
I'm talking about in the cartoon. What if you could try to come up with ideas from that?
There's nothing else from the cartoon, Ethan. Like, we have to think about real life things. Like, error does not exist in a cartoon because a cartoon is exact, right? Error exists in the real world. The reason why we have experimental error is because things aren't a picture perfect cartoon. If you give me an experiment and you give me a cartoon of it, there's no error because that's just always right.
Okay.
Yeah.
Not necessarily. It depends on if the animation is a bitmap or a vectorized animation.
Yes.
Yeah,
Yes, Hypatia.
Any kind of rasterized animation, it will still
Right.
have those.
Yeah, but
If
yes,
it's
so yeah,
also
Hypatia's
vectorially
correct.
algebraic-
Yeah.
Yeah.
But in something like this, Hypatia, right? You know, like, it's basically what it
It's a
is.
bitmap. It's a
Right.
raster.
Yeah, it's a raster.
Like if you put it into Photoshop or JMP and just zoom into the pixel, you will see
Yeah.
it.
Yes.
Like the raster itself is already a
An estimation. It's an estimation. It's an estimation. Yeah. Yeah. But I don't think it's gonna affect this experiment. Like, it's
like this person. Who are you talking to again? Are
Ethan.
they the person who wants to develop games? Yeah.
no.
like,
I don't think
Oh,
Ethan wanted to make
okay.
games. No, that was Nick. Nick wants to make games.
Yeah, well, rasterization and ray tracing, for example, they are very
Yeah.
important to computer vision.
Yes,
and
for
also
making video
computer
games.
graphics stuff.
For sure. Yeah, linear
So
algebra is
teach
very
linear
important.
algebra with it. Yeah, well,
Mm-hmm.
yeah, quaternions or
Quaternions. Oh, that's getting a little complicated.
well, it's the best way to describe rotation. And then physics engines, there are multi-body optimizations, Lagrange multipliers to yeah.
I
different
need
kinds
to
of
go over
things.
Lagrange multipliers. Honestly, I forget them. At some
Well,
point.
it's used in different kinds of stuff to.
I know we use
optimize
it.
over a
Do they use it in
over a
Noether's
hypersurface.
theorem? Is Noether's theorem Lagrange multipliers?
Lots of things
Noether's
named
theorem?
after Aminotta, but I think the one physicists talk about is about symmetries.
Okay.
It's not the one like it's symmetries of energy functionals giving rise to conserve the quantities of the system, something
I
like
see.
that.
I see. I see. Yeah. I remember that. Yeah.
Hey,
All fun
Dr.
stuff.
Go?
But
Give me a
I
second.
think let me see. What's the wait? So non-relativistic electromagnetism is probably the unitary group, and the conserved quantity is charges.
Mm-hmm.
And like rotational group SO3 corresponds to something, and then the conserved quantity is angular momentum, and then there's translational. The
Momentum.
translation,
Yeah.
I don't
Okay.
remember. Like, so basically, you want to assemble all of them into a huge group called I guess it's just a standard model group that unifies these things, and
Mm-hmm.
then you have gravity. We don't know what gravity
We have
is.
no clue what gravity does. Still trying to figure out gravity.
Hey, Dr.
And
Go?
like to quantize gravity probably will be the most undertaking project in whatever.
Yeah. What's up, Ethan? Ethan, what's up?
What were we all saying about a Noethers
Don't worry
theorem?
about that. Don't worry about Noether's theorem. Don't worry.
Noethers,
Yeah.
it's an awesome person.
Emily, right? Wasn't it her
Sorry,
name?
just
Emmy. It's a woman, right? Emily Noether. Was that her?
Yes,
Yeah.
Emmy
so,
Noether is
what
it's
was the
a
theorem?
really
Tell me what's the formula
ingenious
for that.
person.
Yeah. Emmy's cool.
Tell me
Yeah.
what's her formula. Like Pythagoras?
You're not gonna know this formula, dude. Dude, this is high level like vector calculus stuff.
It's
I don't know, I'll just find it
400
myself.
years
I'll find
ago.
it myself.
Yeah, and then another
Yeah, here.
thing.
Do you
Like,
want to learn this? Do you want to learn this, Ethan?
Let me see.
if
Let me see.
you
Hold on. Let me see.
100 days ago, I text you about the
What?
symplectic and the contact structures.
Sure.
I don't know if you
What?
remember. Like that thing is also related to that. It's
Oh, okay.
also related to the energy function. Sorry, not energy, action functional.
Mm-hmm.
What on
There
earth
are
am
a
I
lot
seeing
of
here?
to be
Could
talked
someone
about.
follow this? Is what the hell?
I know. I told you, Ethan. Don't worry about this, bro. We need to teach you how to like crawl before you can like run a marathon. That's what this stuff is. This is very high level
Okay,
math stuff.
what is it? Why is the sum of sign above an A?
I
What is
know.
an A?
Don't worry about it. Don't worry about it. The first
what's
programmer was a woman,
What's this
was it?
Yes,
and what
Nota
is this
is a
infinity
woman.
sign?
Actually, Nota is one of the idol of
Oh, Ada
generation.
Lovelace, really? Oh, she was. Oh, that's cool. I didn't know
Yes,
that.
Ada Lovelace is a computer scientist.
Oh, that's cool.
Actually, it's not only like say Ada Byron Lovelace because Lovelace is a bad partner's name.
Oh, but she had to keep her abusive husband's name or something.
Byron is the birth name.
That's cool. Or Lord Byron. Wait, isn't Lord Byron known for something?
Poetry, I think.
No, what is he known for, dude? This guy's known for something.
Poetry, literature, stuff like that.
Lord Byron. Fuck, where's that coming from? I know it from somewhere. Yeah, he was a poet. 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 Yeah. Uh-huh. Okay, that's cool. Okay, here, Ethan, let's finish your question before like I start going into all this other stuff.
Yeah.
Okay.
What could be one last reason?
Yeah, I'm trying to think one
the
last.
water level was not precise.
Yeah. Well,
Wait.
we already have that, and then
Which one?
Oh, you know what else we could do? Well, never mind. No, we can't do that. I'm trying to think of something else.
Tell me what you were gonna think.
I was thinking if the density of the water mattered, but it doesn't. Okay, here we go. Here we go. Some of the rock dissolves, I guess. Dissolves into the water. Which would cause an
Wait, what is
undermissing.
this question about?
It's I don't know. It's some lab question for his science class.
Well,
Well, not really a
about
loud
the,
question, but it's like something based on a lab question, or
Yeah.
like what will happen in labs.
Honestly, I think this question's fucking stupid, but like it's okay.
Yeah,
Yeah,
I think this
if
is
you
so
want,
stupid
if
as
you
well.
want my
I'm kinda-
honest opinion about this question, but it's okay.
Look, I really do think this is a stupid question. Like, I'm really starting to hate physics at this point.
No, this isn't physics, dog. This is just garbage, dude. This is not physics. It's okay. Whatever.
Yeah,
Alright.
what about the other one?
Okay, I'll do the other one. Give me a second. Just hold your horses. All right, here we go.
Don't look at chat.
The chat's going off like crazy, dude.
So, and see, here, let me say something about this. Let me say something about this.
What?
So here's what I'm thinking. I remember, you see that red bar there? You see that red bar under that thing there?
Yes.
That's like, I was watching this from a video. Okay, this is a video.
Mm-hmm.
And so since I saw the video before this, I know what was happening. It's like you're taking this ruler and you're measuring a penny.
Yes.
And this video had taken a ruler but measuring a balloon. It's kind of hard to find the exact length of something since it's completely round and there's no like straight shape. That could be
100%.
an error.
Oh, but are we asking for error in this, or are we actually they want the error in this thing?
Pretty sure they want the exact same thing. I mean, hold on. I could try to type in this thing, the things you sent me real quick.
Okay.
So why
Is-
don't you do someone else's question while I type these
Okay.
three out?
Okay, let me do it up. Let me do someone else's question. Yeah, cool. Is Geodude is breedable? Stop. Who is Geodude? You can't- Oh, this guy, Geodude. Yeah. That's funny.
Oh my! Is that a damn Pokemon?
The Pokemon, dude. Geodude the Pokemon. That's too funny. Y'all gotta
The
chill,
Dark
dude.
Aspect was just called the EDP by me. You already know.
What's the EDP?
EDP stands for Eat That Pussy 445. That's actually the YouTube channel name. I'm not even lying.
Really?
EDP is a child
It's basically a
predator.
child molester.
It's a what?
He's a child predator. No, he's a predator. He got caught
EDP's
twice.
a child predator? Oh, dear.
Yeah, he got caught twice. He got caught by Gideon and some other dude.
You guys, dude. There's too
You
much
dark when
going
you
on.
find the
Is that the goal?
cupcake.
Just look at my internet though. I go crazy.
I don't think I want to look these things up. Especially not on a stream.
Totally not 302 megabytes per second.
Oh, I saw. Oh, you're updating the game. Nice. Okay, cool.
No, I'm not updating a game, bro. I'm downloading GTA.
Oh, okay. Cool. GTA's cool. I think I
And
had it
that's
downloaded,
80
but I haven't.
gigabytes.
I think
So-
it was free for a while, wasn't it? Wasn't it free for a while?
It's on Game Pass. That's how I got it right now.
Oh, okay. Yo, Teacup, where you at? You here, Teacup? Do I have to ping you?
To go. Hold on. Does that go?
Yeah. What's up, dude?
So I want to ask you questions about meniscus.
Okay. What do you want to ask about the meniscus?
Is it
Is
MEN?
Oh.
Is it MEN?
Oh. Did I spell meniscus wrong? Probably. Yeah, it's MEN.
You said
Yeah.
MIN.
Yeah, sorry, it's men.
Wow.
A mug will like that. It's men.
Oh my goodness. He might think something weird. Like it begins with the word homo. I know he will think about that.
Let me, please.
No,
Hello.
come on.
What's up,
Let's go,
Teacup?
Chica.
Teacup.
Chica, big W.
Big W, dude. Okay. Can we like stop doing this question? This one like hurts my brain, dude.
Oh dang.
Which one?
And also, flip the rock.
Yeah, this one really
Green.
hurted my brain. I don't want to do this one anymore.
Then do it.
Here, let's find something else. Let's find something else for you, dude. This question's like hurting my soul, dude. What page was that on, dog? By the way, do you remember?
Oh. We've been doing this,
What's up, Nick?
4 hours. It
Okay.
was page 254 of the PDF.
Okay, cool. Thank you. Page 254. 254. Sorry. Oh, okay. We got a bunch of oh, yes, it was this fucker. Yeah, all right. Yeah, that one was kind of hard. All right, let's try to see. Ooh, you know what I like? I kind of like these basketball ones. These are fun. Wait, no, I don't really want that. What chapter was this?
Expand.
Oh, applied optimization. Excuse me. That was Snell's Law. Where was like kind of a fun one? Dude. I gotta put this one on just because it's funny, dude. Oh god. Here we go. My sides, dude. All right. Here we go. All right. Says the rectangular plot in figure 23 has a size of 100 meters, okay, by 200 meters. And pipe is to be laid from point A to point P all the way to point C here, where this is this, okay? Okay. And now, what they're asking you, so they say the cost of laying pipe along the side of the plot is $45 per meter, and the cost through the plot is $80 per meter. Wait, let's see. Okay. So they're saying the cost here is $45 per meter, okay? Whereas if you're laying pipe here, this is going to be $80 per meter. Okay? And here they're saying, okay, let f of x be the total cost. So we're going to say f of x, right? This is the total cost. Where x is a distance from P to B, right? So x is the distance from where you start putting the pipe here along the side versus running it across the diagonal, okay? And they want to say determine the cost. But note that f of x is discontinuous at x equals 0. Okay. Right, that makes sense. Because see, if x is 0, right? So if you start, like, doing this, for instance, then everything is just $45 per foot, right? Okay. Cool. All right. All right, cool. All right, so let's try to do this. So, total cost. How do you think we start this question? How do I figure out the total cost of the pipe? Try to, like, just use words for it.
Well, first we'd have to find the length of the pipe.
Good. All right, so how do we figure that out?
Let's see, if 200 minus x. Couldn't we find the, you see where it says 100x? That makes it end. It makes a triangle on
Good.
that.
That makes a triangle. Very good. Okay.
But we need to get x first.
Well, optimizing means we're gonna vary x until like we get a certain amount of, like x is the x is the knob x is the knob that you turn. You can leave x in the equation, but you are right that we need to know what Ethan.
Okay, so I just had the question, but it gives me something completely different.
Okay, cool. I'll look at it. All right. So we need this length is what we need. We need the length of this, right? Because the cost of
Hold on. What is going on in office hours chat?
just don't worry about it. Worry about the question you're on right now, dude.
Okay.
Don't be distracted. Okay. How do we do this?
Well, we do the Pythagorean theorem.
Good. Okay. So what is this length? What is that going to be?
Well, let's see. So it would be 100 squared x squared equals whatever that is squared.
100 squared plus x squared, right, is equal to, yeah, whatever this is squared, right? But I just want this distance. I don't want this distance squared. So what do I do?
Square root it all.
Square root all, right? So this becomes d is equal to the square root of all this, okay? So the square root of 100 squared plus x squared, right? That's the distance. That's the distance of this. It's okay. It's not a number yet, all right? Then what is the cost of that then?
Okay, so after we figure out how long it is, I'm assuming it's in meters.
Good. It is in meters, yeah. And then what would you do to get the cost?
80 times. No, it would be.
Yeah, good.
80 times the amount of meters.
Good, exactly. Good. Yeah, do you see how, so $80 is the cost and this is the amount of meters? Okay. Good. So that's the cost of laying the first amount of pipe. What about this amount of pipe?
200 minus that.
Good.
Uh,
Times what?
I could just turn that into. If we do 200 minus x minus x, well.
No, because
plus
remember this
x
whole. No, this whole thing is 200, right? This is
Uh,
x, so this is 200 minus x.
So yeah, it's 200 minus x.
Okay, good. Times what?
Crap. Let's see. So we need to do. I am so confused. Hold on. So we
Okay.
need to find the 200 minus x part of this. We already found what x in was.
No. 200 minus x is just the distance of this, okay? So what's the cost? How much does it cost to lay that amount?
No, 200 minus x. 200 minus x times 80.
45.
Oh. What? Why do we have 80 there?
Because this part, laying anything diagonal costs 80. Laying anything along a side costs only 45.
No, doesn't it say 65 in the equation though?
Does it? Where?
See
It says here.
above that
Oh no.
triangle.
Oh. This is they say that this is the second part. They say
Oh, okay.
yeah. Okay.
Hmm.
This is the part 80 and 45.
So times
Okay.
45. And
Good.
then we do it all.
Yeah, exactly. So this becomes actually a function, right? So yeah, this is 100 squared plus x squared all to the 1/2, right? Times
Yeah.
80 plus
Plus
what?
200 minus x times 45.
So that's
That'd be
200 times 45 minus 45x, right?
minus 45x.
Okay. Good. That's the cost. The important thing here, the reason why this is an optimization problem, Teacup, is this is the cost in terms of one thing. One thing I'm changing,
Let's do x over infinity.
which is just x. Well, it's just, do you see how, like, if I plug in different values for x here, the cost is going to
It would
change?
change.
Yeah. Okay. So, if I want to figure out the most economical way to lay the pipe, right? What do I want to do to my cost? Do I want to make it the biggest or the smallest?
Smallest.
Smallest. Good. Okay. Good. Yeah. Oh, cool, Cosmic. All right. So this is applicable to what you're doing right now. Yeah. So you want this to be the smallest. Okay. What do we learn about, like, functions and derivatives and things? Like, how can we use a derivative to find when a function is the smallest?
When it's at its minimum.
Good. And what is the derivative of something when it's at its minimum?
I wouldn't want to say 0.
Yes, the first derivative is 0. So first derivative being 0 means it could be a min or a max, technically. You have to, like, kind of check. All right?
Yes.
And then you have to technically check, like, the endpoints is what we say as well.
Oh, I hate the endpoint.
Okay. So I'm going to say that the minimum, right, occurs when the first derivative is probably equal to 0. So let's try to figure out where that is, right? This is kind of a mess to work with, okay? But I can try this. I can say, okay, what is the first derivative of this, right?
So first derivative. Oh wait, so we got 100 plus. No, we got 200 plus 2x.
No, it's
Oh,
no. This is a chain rule, first of all. Okay, look.
oh damn it.
This is 100 squared plus x squared all to the 1/2, okay?
Oh, let me
So
just
the
do
issue
that
is, I don't know what the derivative of this all to the 1/2 is, right? But I do know, right, what the derivative of something to the 1/2 is, right? What's that?
It would be negative 1/2.
The power would be negative 1/2, right? Good. So I'm going to write this as 1/2 100
Times
squared
everything.
plus x squared to the negative
Times.
1/2
Yeah.
times what? What do I? This is
Times.
called the chain rule. So what do I have to do if I do the chain rule?
We got distribute.
Good. Well, no. I have to do the derivative of what's inside. Okay.
Oh, okay, so we have 200 plus 2x.
No. 100 squared is just a number. Derivatives of numbers are just 0. Right? There's no
Right,
x in it.
Oh
right?
yeah, 200. That turns into 0, and the x squared turns to 2x.
2x. Good. And then I still have the 80 out front here as well. right from here.
I don't like that 80.
Okay, plus, what's the derivative of this? What's the derivative of 200 times 45? 0, good.
0, and then we have 45x.
What's the derivative of 45x?
Okay, so it's negative 45, and that's
Yeah,
that
good.
1, so it'll be 0. So
It's just negative 45, right? Because x to the
Yeah.
0 is the same thing as 1. Okay,
yes.
good. Okay, cool. All right. So now I have this big, big, messy thing, and I want this to be equal to 0, right? So let's try.
Alright, so here's what we're gonna do. We're gonna do plus 45.
Good. Yeah, we can move that over, right? So I'm going to combine this. So the 1/2 and the 80 is going to turn into a 40. Oh, but then I have another 2x, so this is going to be 80x. So I have 80x, right? All over. And then this is a square root on the bottom, so this is the square root.
100 Square root
Mhm.
of 100 squared plus x squared
X squared is equal to 45.
equals 45. Yay.
This is kind of a mess, TBH.
The hell is TBH?
To be honest.
I use abbreviation. It's not that long.
That's okay. That's okay. Here, I can move this over. Let me move this whole thing to the right side.
We're gonna multiply.
Good. And then what I want to get rid of this x squared. I want to get rid of this square root, sorry. So I'm going to square both sides. So this is going to be 80 squared x squared is equal to 45 squared, and then this is 100 squared.
That doesn't
plus
look
x
that
squared.
doesn't look that good.
It's not looking too good. But it's okay. It's not too bad. Okay. So now I can start, so I can move this over if I wanted to, right? I can say, okay, cool. This is over
Just divide it
45
back
squared.
over the way it was.
I know. Okay. And then what do I want to do? Minus the x squared, I guess.
Sure.
Dude, this is becoming such a mess, dude. It's okay.
Let's just not do it. How about we just put it into Wolfram mouth?
No, it's okay. We're gonna do it. Okay, so here's what I'm gonna do. I solve this thing, right? 80 squared x squared over 45 squared. And then I'm gonna subtract x squared on both sides. But subtracting x squared, if I want to combine these fractions, do you see how this is minus 45 squared x squared over 45 squared x squared? Or
Yeah, we
just
can
45
do that.
squared? Because now I can combine these, right? And this is all equal to 100 squared.
What
So
the hell
now,
am I-
combining this, right? I have... Okay, and then let's move the 45 squared on the other side, right? Let's just
What
get
the
rid of
hell?
it. Yeah, we're going to get rid of it. We're going to put it over here. Okay. So now I have 80 squared minus 45 squared, all times x squared, is equal to 100 squared times 45 squared, right?
Can we just do 80 squared minus 45 squared?
I don't want to do it. Those are really big numbers right now. Okay. So
We gotta
Mm.
divide it by the least
Yeah.
common multiple.
no.
Well,
Now
not
we-
least common, greatest common fact.
Yeah, now we just square root it. So I say x is equal to... The cool thing is that, like... well, none of this is cool, actually. This just all sucks.
Yeah, but
Well, the square root will get rid of these, so it's actually 100 times 45, which is nice, okay? But then it's divided by the square root of 80 squared minus 45 squared. Yeah, I think so. We'll see if this answer makes any sense. Again, I was trying to do this without using the calculator as long as possible. And this is a good trick for you guys. It just means you're going to waste less time, writing out numbers. Like, for instance, I could have figured out what these numbers were, right? But they would be really big numbers. And you're going to end up wasting a lot of time writing that when I could just write, 100 squared. Okay, so let's get our calculator out. See what we got. So I got 100 times 45 divided by the square root of 80 squared minus 45 squared. Oh, okay, cool. And so we get 68. That kind of makes sense, actually, 68. It's an okay number, all right?
that's
So
not
that-
bad.
So yeah, so that tells me that, so where I want to start laying, like, the straight pipe here, I want to do it when this is around 68. Seems reasonable. Cool. Nice.
Yeah, good enough. But then you realize that 68 is it's going to be a bit expensive for your 2,000-meter long yard.
Yeah. Well, we could figure out the actual cost by putting that number into here and figuring it out.
No, I'm good.
But yeah, we don't really want to. Technically, you're also supposed to check the endpoints of just doing this and this. So that
No,
would
I'm
be, yeah. But that kind of makes sense because then the cost would be, yeah, 65 meter. Okay, cool. All right.
Cool.
I
I
have-
want you to zoom out real quick and just look at it.
Well, it's not that bad.
That's not that bad. Compared to the crappy equation we've been doing.
Yeah, no, it's okay. Did I give Ethan
should
a
look
bond
it
coin
up.
for his question yet? Did I give one for him? I don't think I did.
My question is completed as yet. My question is completed as yet.
Okay, cool. All right.
That's cool.
What's up, dude?
I have the next
I got a
string.
question.
Okay. What's your question?
Like, I don't know if you're nerdy about this shit, but like,
I'm pretty nerdy.
does internet give out radioactive waves to get into your devices, like shit
do you
to
mean?
take the internet?
Not radioactive. They give out microwave waves.
Yeah, everything has what's called like EMR, which is electromagnetic radiation. So yeah, any sort of device that's using any sort of like wireless or anything is going to give off some sort of radiation.
Pretty sure cell phones.
Did you know the
have
iPhone
microwave.
12 had like, I don't even know, it was banned it was banned in Paris or France or something. The iPhone
Mhm.
12 got banned in the EU though.
What? Because of the radiation?
Yeah.
Oh, that's weird.
What kind of knobhead uses Apple though?
What a no bad.
Luckily, I don't spend $30,000 fucking dollars just to get an iPhone, bro.
They're not 30
I
grand.
swear.
Ethan, where's your question?
know.
Where did you type it, dude? Where did you type it?
I'm ready to send it.
Oh, send it to me. Send it to me right now. Who we got here? If it isn't the best education channel in the world. Thank you, Kiss Killer. That's dope. Okay, let's see. Okay. The best. Y'all are the best, dude. That's the only reason we're the best. We're the best because you're the best. What's crack-a-lacking, Kiss Killer? How's life? How's the discovering math on your own game? What were some of your sources of error in your silver nitrate experiment during day 1? Try to list at least 3. Okay, but
See,
what?
I'm not.
What was your silver nitrate experiment? This is not physics, by the way. This is chemistry.
This is so confusing. Like, wait, I don't get it. What is that, anyways?
So silver nitrate is AgNO3. It's a solution of things.
I don't even know that. I don't even. know
Because
that.
I teach a lot of chemistry, so I know what silver nitrate is. They do. ADHD
Alright.
jumps me all the time, dude, man. Seriously. Okay, yeah, I don't think you can do this question, Ethan, because do you remember doing something with silver nitrate during day 1? I don't think you did. Also, this dude is someone else. Is this guy actually your? Did he make this YouTube video? I don't think he did, right?
Ooh.
Your professor Kyle Hung. Did he make this? Did he make this video?
No. This is already posted. This is
So-
already posted
so
on
I-
YouTube.
I think this question here is talking about something else in the video that you haven't done yet.
Okay, then.
Yeah. Unless you can show me something else that has silver nitrate in it. I don't see anything else.
What is a silver nitrate? Like, could
It's-
you show me
it's-
an image?
Yeah, it's just water basically. Right. It's a powder.
What if it was in the video?
All right. Well, maybe. I mean, this is what it is. It's like a powder.
Okay.
Yeah, that's silver. Looks like a white crystalline powder. It's pretty cool.
Look, I don't think I've seen this. I don't
Yeah,
think
it's usually a
seen this at
liquid.
all.
They usually have it in what's called aqueous solution. So they usually mix it with water. That's what it usually is.
Yeah, but I don't think I've seen anything like that.
Yeah, that's why I don't think the question is applicable. Okay, let me see.
Alright.
Cosmic has something cool. What up, Cosmic?
Yeah. Could you did you give me the bonk right now?
I did.
I haven't seen it.
I'm pretty sure I did. Yeah. Oh, I gave teacups. Sorry, I didn't give yours. You're right. Give me a
Okay.
second.
Alright. Well, thanks. I'll try to ask my classmates or one of the people who
Yeah, ask
does
them what
take
they want with the
physics.
silver nitrate, because that didn't make any sense. Okay, let's see. We got a little toughy one here. This looks like some physics. A uniform 2-meter long rod has a mass of this suspended vertically from a frictionless pin in its upper end. A 4-gram bullet hits it and strikes it below the pivot point. Determine how high the bottom of the rod swings above the datum. What is the datum? Oh, they call this the datum. The bottom. That's cool. All right. If the bullet remains embedded in the rod. If the bullet goes through the rod. Oh, wow. And leaves with the speed of that. Oh, interesting. Okay. This gets a little hard. Okay. I think it has to do with center of mass, is what this is. Yeah, I think this is still a center of mass question. Okay. And then the center of mass is going to change, actually, because when the bullet embeds itself in the rod, the mass is going to change. Kind of a mess. But all good. I think we can do this one. 331. Okay. All right. Energy before, energy after. Energy before. So this is going to have a center of mass at 1 meter, is what we're going to say. And so this distance right here is going to be 0.4 meters. So before we have the potential energy of the rod and the bullet. So that's going to be mu of the rod plus mu of the bullet plus Ke of the bullet. Which is going to equal yeah, okay, so that's gonna be, what is that? That's 0.82 times 9.8 times 1 plus 0.004. It's a very small bullet. Plus 9.8 times 0.4 plus 1/2 times 0.004 times 268 squared. So that's the energy before, when the bullet is flying towards this rod. And then once it embeds itself in the rod, this whole thing is going to like swing upwards a certain amount. And what we're going to look at is what's the maximum potential energy of this rod plus bullet system. And I think we can approximate it as like a center of mass thing. Yeah, we can approximate. This bullet really isn't going to change the center of mass of the rod by very much, because this is 820 grams compared to 4 grams. But technically, there is going to be a little bit of a difference. So, okay, so energy after. We're just going to have the potential energy of the rod plus the bullet. Which is going to equal, right, so that's how high the bottom of the rod. So, okay, so they want how high the bottom of the rod swings. Okay, got it. So that's going to equal to the 0.82 plus 0.004 times 9.8 times some new height. And then I'll show you how this all like kind of works. Okay, so where's my calculator? I need my calculator for this one. Good old engineering, just giving so many numbers that you have to solve for. It's so annoying. I would like this if this was just in variables. I could do this in just in variables, but the fact that they give you all these numbers is super annoying. Times 0.4 plus 0.5 times 0.004 times 268 squared. Big number. Well, not that big, actually. Oh, so that's 151.7 joules. Okay. So this has to equal energy before, right? So H is going to equal E before divided by all this 0.824 times 9.8, right? Oh, I guess we couldn't have gotten rid of the 9.8 because there's a kinetic term. Yeah. Okay, whatever. This divided by 0.824 times 9.8. It gives me a height of, well, that's a lot. I don't think it can go up 18 meters. No. that's not right. Oh shit. Okay. Let's see. Something's wrong. Oh, you know what we have to figure out? Oh. Sorry, first we gotta do conservation of momentum. Yeah, my bad. I forgot about this. So this is going to be... yeah, because you have to do what's the speed of the bullet plus the rod. So we say connection of bullet plus rod. Uh-huh. I see. Yeah, man. Ooh, that is tricky. Okay, that's okay. Just gotta change some numbers here. So this is 0.824, and then this is V of rod and bullet. Okay. The way to figure out the velocity of the rod and the bullet. So here we're gonna say is we're going to say P before equals P after. So 0.004 times 268. That's the momentum beforehand. Is going to be equal to the mass of them together. So that's 0.800, or 0.820, sorry, plus 0.004 times V rod and bullet. So V rod and bullet is equal to something else. So what is that? So that's 0.824. Wait, no, so 0.004 times 268 divided by 0.824. Right? Yeah, okay. Much slower. Much slower. Yeah. Yeah, wow. That's 1.3. Okay, so now we get rid of this. So now we have 0.82 times 9.8 plus 0.004 times 9.8 times 0.4 plus 0.5 times 0.824 times this number. Much better, 8.588. This is 8.588 joules, which we're then going to put into here. Okay, so that divided by 0.824 divided by 9.8, much better, 1.06. Okay. Last step we got to do here is now I need to take this. And we have to think about like what the system is here. Well, like what the center of mass is. It's kind of weird. So, because that tells me what the center. Okay, so first of all, let's find what the. So here we need to find center of mass location of bullet and rod. It's 2 meters. So that's going to be 0.82 times 1 plus 0.004 times 1.6 all over 0.824. I don't think that's going to change very much. Could. Let's see. 0.82 plus 0.004 times 1.6 divided by 0.824. It's basically 1. Yeah, okay, so I'm just going to assume it's 1. If your teacher really gets mad about that, like basically being off by that much, like whatever. Okay. Now the last thing is to draw like a little diagram. Okay. So we know this distance was 2. There's some new distance where from here to here is 1.06. Okay. And they want to know this. They want to know this amount. Okay, cool. And we know that this distance is 1. And this is 1. Geometry gods. Where are my geometry gods these days? I want to know this. Is this kind of like an inscribed circle? I'm trying to think what it is. Okay. Something like this. What does that really tell me, though? Oh. Oh, okay. I see how we can do this. This right here is 1.94. Or sorry, 0.94. I know this is 1. So then this makes a triangle, right? Aha. And this also makes a triangle. Oh, very cool. I'm starting to see it. And then this makes an even bigger triangle. Okay, cool. Okay. So what I'm going to say is 1 over 0.94 is equal to 2, because that's the whole thing here, divided by this. This is going to be x over x. Very cool. Okay. So then 2 divided by 0.94 be 2.12. Wait, doesn't the whole distance have to add up though? 2 to 2. Oh, okay. No, no, no. Yeah, I got it. Well, Right. 1 over 0.94 is equal to 2 over x. Should be smaller. No, right? Oh, no. Okay, no. Okay, yeah. Sorry. 2 times 0.94. Okay. Algebra's going a little wonky. Okay, so x is equal to 1.88. Okay. Oh, so then the edge isn't really that far off, is it? So 2 minus 1.88. .12 meters. That's all it is. I think that's it. Cosmic. Yeah. Tell me if that's right. I'm curious. Yeah, there's a lot in there. There's you have conservation momentum, and then you have conservation of energy, and then you also have to do some weird geometry with center of mass in order to figure out what it is. I think that's correct. I'd want to see if you know if I got any, because if any of these numbers are wrong, it's going to throw everything off. This is why I don't like engineering, because if I happen to mistype one of these numbers in wrong, it just won't work. So if that's right, then doing the second part is not so bad, because the only thing that changes is that the bullet does not stick in the rod. So not only will the velocity of this rod as it swings up be less, but also the mass will be less, because the bullet's not stuck in it as well. Although the bullet is like really tiny. The bullet is 4 grams, whereas the rod is 820. So the mass of the bullet really doesn't make that much of a difference, as we saw when I was like trying to calculate the center of mass here. This was like, center of mass was basically 1. It's basically the same thing. Yeah. I'm curious. See if that's right. Okay. All right, Nick, you want to do your question? Thanks for waiting around, Nick. That was a long one. And technically there's a part 2 on it, but I need Cosmic to prove to me that part 1's correct first before I do part 2. Okay, cool. All right. Which one do you need help with, Dark? Which one?
Come again.
What's up? What's up, Ethan?
I did number 9 and 10.
Okay.
And I got them. One of them was -3 and one was +3.
Okay. What, for QS and PR? Yeah, that makes sense.
Yeah.
That makes sense. I mean, you can look at this, right? Do you see, like, if I go from this point to this point, I go over 1, but I go up 3? Whereas I go from this point to this point, right? Sorry. I go down 3 and over 1, right? So you're right. This slope is -3. This slope is +3. Okay. We ask, is it a trapezoid? Right? A trapezoid occurs when these two are parallel and these two are not. Okay? What's the slope of PQ?
I did not find it.
Well, you can see it. It's a straight line, Nick. What's the slope of a straight line?
5?
5? What?
No.
What's the stroke? What's stroke? I'm having a stroke, dude. What is the slope of a horizontal line? Just going this way. What's the rise over run when it goes from here to here?
0.
0. So yeah, this has a slope of 0. This has a slope of 0. So it's a trapezoid. Okay. Give me a second, Ethan. I'm working with Nick. Find the length of PQ. How do I find the length of PQ?
Just the distance.
Yeah, distance, right? I mean, you could use a distance formula, or you can literally just count it, Nick. Look, 1, 2, 3, 4.
Yeah.
Right? See how that's just 4? What's the length of RS then?
1, 2, 3, 4, 5, 6, 7, 8.
Good. Okay. All right. What is the relationship between the RS and the PQ segments? Okay.
I don't know what that question is asking me.
When they say relationship, they're usually like, how does one vary as a multiple of the other? Okay. So if RS is 8 and PQ is 4, what does that tell you is the relationship between the distances? It's double. It's double. Yeah, you would say like RS to PQ. You remember ratios, dude? Let's say it's the same as like 2 to 1.
Oh.
Yeah, that's a relationship. Like one is twice the distance of the other one. I think.
Oh, okay.
Pretty sure.
Yeah.
Yeah, I don't know why they're really telling you that. Because that doesn't really like help you out with anything. There could be something cool with the slopes, for instance. I think if the slopes are something, then something about this happens as well. But I don't know. Yeah. Yeah, that one. That's not too hard, Nick. You should know how to do that.
Yeah.
Yeah. Well, what's hard about it?
I don't know. I was just making sure because they both look the same, and for some reason I got one negative, one positive.
Yeah.
I was a little bit
For the
confused
slopes? Yeah. Well, because this one, Nick, this points up, right?
there. Yeah.
This one points down. That's why it's a positive slope versus a negative slope. You're right that they are the same, but they're opposite signs.
Yeah.
Okay? If they were the same, then this would be the slope, and then these would be what we call parallel. That would make a parallelogram, not a trapezoid, right? This would make a parallelogram. Okay? Cool. Love it. All right, Ethan, what's up?
All right. So I wanna say something about that silver nitride thing.
Okay, what's up?
People, my classmates were asking me, or not asking me, but they were asking each other like, "Have we ever done the silver nitride experiment?" And I even talked to another one, and they said to just tell my teacher if it was an error, like, this was an error. We never did this.
Yes,
So
I think that's what happened. I don't think you ever did it.
Because it's like since we take physics, there's another class who takes all the 3 sciences. Science is like that's how it is. So I guess that's why we got asked that question, even though we never take chemistry or biology. So yeah.
Okay. Yeah, that's interesting. Yeah, no, I think it was just like an error. Is what it was. Dude, look at that. Do you see this question, Ethan? Do you see one of Jamarcus's questions?
Oh.
Find the total number of ways a white and black king can be placed on an empty chessboard so that it is an acceptable position according to the standard chess rules.
Bro, I want to do this question.
You want to do this question? You want to do this one? This one's kind of fun, right?
Yes.
Let's get it.
Always with chess. I want that.
Okay, well, let's try and do it. I'm curious. There's kind of a math thing to it, but let's see. Let's do. I need an image of a chessboard.
It's just 64 squares.
I know, but I want to animate it. I want it to look cool.
What do you mean you want to animate it?
I'm gonna show you, dude. I'm gonna show you, dude. Watch. Okay. So, all right. The total number of ways a white and black king can be placed on an empty chessboard. Okay.
I don't get I don't get the first part.
Yeah.
The
okay.
total ways, like what?
So watch. So let's say that this is, let's say this is the white one.
Do
And let's-
white. Do white as white.
Well, no, because the board pieces are white. That's the problem. Okay, whatever. I can do the. I gotta do this one then, or this one. No, this one. You see how I can't put a white thing on a white board because then I won't see it. Okay, whatever. All right.
No, I mean, do the circle of white. That's what I was saying.
Yeah. Okay. All right. Okay. So we have a white piece, right? And then we also have a black piece, right?
Yeah.
Okay. So let's say, for instance, I put the white king here, okay? Where are all the other positions that I could put the black king? Could I put it here?
Oh no, you can't. So go back to your original square.
Okay.
Let me see. You can as I'm looking at this, if you were to play actual chess, you can move the king in like I think 5 ways, right? You could play it on d6, c6, d6, d7, and d8.
Oh, the
and
black
c6,
one, yeah.
c8.
Yeah, but they're just saying where could I place it? Like, let's say the king is off the board, okay? And I want to put it somewhere on the board. They're saying like where are all the places that I can put it, right?
But you can't put it. You cannot put it on b8, b7, and a7.
Right. You can't put it here. You can't put it here, and you can't put it here, right?
Because it's like imagine they have stinky breath.
I like that. They stinky breath. Yeah. Okay. Okay. Cool. So like you said, right? There's 64 total squares, right? So I would say like if in the corner, then there's only 60 places you can place it, right? Because it's all 64 squares minus you can't put it in these 4, right?
No, hold on. Here's what I'm thinking.
Okay.
That's just on the edge. What if you centralize it? Then
Good.
that's
Yeah.
more
So yeah,
squares.
exactly. Let's do the different conditions here. Okay. So we did the the corner. All right. Let's think about an edge. Okay. Let's think about an edge here. Let's say this edge, right? Where are the places I can't place it now?
Well, you can't put it on a8, a7, b6, b7, b8.
Right. Or a7, right? I can't put it anywhere here, right? So that's
Yeah,
all the
you can't.
positions minus 6, right? So here we're going to say, right? So on edge, that's going to be 64 minus 6, which is going to be 58
Or you could
places.
You could put it on the rim. You could put on rim.
Oh, you want to say rim? I like that. Oh, yeah. Let's say it. On the rim?
Yeah.
Okay, sure.
Because I heard a phrase, yes, and a knight.
Mm-hmm.
People say a knight on the rim is them.
Nah. A knight
Or
on the rim
grim,
is them.
as you would
Is grim. A knight on the... Yes, I like that. A knight on the rim is grim. Yeah. Because if your knight's on the... Yeah, because it knocks out half the moves it could make, right?
Yeah, but I like using the word them better. But what's rim and grim? Sorry, what's dim?
Dim is like not bright, so like kind of like dark, and then grim is like deathly, like invoking death.
Dude, if it knocks out half of its moves, how is that involving death?
Because the knight will
We're
probably
sad.
die, right? Because the knight will die because it can't. Oh, what's up, Destiny?
It doesn't have many moves.
What's up,
so
Destiny?
It doesn't have as many places to go.
Exactly right. It's grim. Yeah.
So
right.
it's more easily trapped. So like grim can also just mean like like dark. Like you ever heard the term ominous?
Ominous. That's a good one.
Yeah.
Yeah.
So
Fake grim to
what,
ominous.
Just like not good.
ominous wind?
Ominous is just like not
Yeah.
good. Yeah, not good, dude. Like not good.
Right, because in chess, the king can just trap the knight, and no matter where it moves, the king will just get it in the edge on the edge. Or the
Sure.
rim.
Sure. Okay, so we're almost done with this question. So if it's in the corner, there's 60 places and there are 4 corners. Okay, so that's 240 different combinations you can have, right? And then on the rim, it's 58 places, but how many rims do we have, right? So I have 3, so I got 6, so I got 24. So we have 24 rims. So that's...
Okay, where did you find the rims? Where did you find the rims?
The rims are just anywhere on the edge that isn't a corner,
Oh, okay.
right?
So,
that
like-
that's a lot.
Is that from A7 to A2 and B8 to G8 and that stuff?
Mhm.
All right.
I don't know why it says that too. I don't know. It's weird. Okay, and then okay, and then let's say like everywhere else, right? So everywhere else would be like
okay.
right here, for instance, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
Minus the 6 of 4.
Good. So that's 55. And then let's think about it. All right, if we've already used 4 corners and 24 rims, how many other places are there?
I have no idea.
So how many?
4 corners and 4.
4 corners, 24 rims. So that's 28 spots. But how many spots are on a chessboard?
6 of 4.
Good. So you do 64 minus the 28, right? See, that's 36.
All right.
Okay, good. So now we do 55 times 36. Oh, wait. Yeah, good. 55 times 36. That's 1980. Okay, great.
Are you doing that on a calculator?
Oh, yeah, sorry. I'm not showing my calculator. My bad. Yeah, there you go.
Dang.
So now I add all
wonder
these
you-
up. I add all these up. I do this plus this. Oh, ooh, I didn't do that right. That plus that plus 240. Okay. That gets me 3612. Okay. But then we also need to multiply by 2 for switching the black and white
where?
pieces.
Okay.
So I think the total is going to be 7224.
That's
Yeah.
a lot of spots.
Lot of spots. That's a cool question. I like this one. I like that you got involved with this one too, right? Because it involved chess, right?
Man, if people are asking questions about this, why don't they play the dang game
I know.
itself?
Because this is just a math question. They're just being weird.
I actually joined the chess club at my college recently.
Hell yeah, dude.
and I've been playing since I was 6, but these people are kicking my butt. And I'm finally, I'm learning what chess like really is. It is nothing. It is. There's a correct set of moves, right? There's a correct response to every move your opponent makes, right? And once you understand the rules and you can make those correct moves, it has almost nothing to do with what you do on an individual move basis. And it's about where you can lead the game to what you can make your opponent do.
Oh, I like that. So you're not really playing for yourself. You're playing to force your opponent to do things, kind of, is how you would describe it?
Yeah, basically. Because once you understand the way that there's multiple levels to this. First level is understanding how the pieces move.
Exactly.
And that doesn't get you all that far. Once you know how the pieces move, then you can avoid making just really stupid mistakes.
Yeah, making dumb mistakes, yeah.
Right. And then, like, once you can get to the point where you understand how to make other people do the shit that you're trying to get them to do, then you're getting to the point where you're on an elevated plane.
Oh, I see. That's cool. So it's almost like a game of influence. You're trying to influence.
That's you get to the point where you can set traps and you can really start playing above the level of regular minds.
Yeah, Ethan is really good at chess. He's he's I think he's probably rated, I would say 1600 probably ELO, like real life.
Damn good.
Yeah, he's really good. He's beaten me, like, and I'm probably around 1200, 1300. But it is.
So people.
Yeah, go on, Ethan.
People don't stand a chance against me like that.
Yeah, you are very good. But Ethan,
there's always a bigger fish.
That's what I said. That's what I tell him. He's like, oh, I've already beaten everyone, like, in the Discord. I'm like, yeah, but there are infinite challengers on chess.com. like
set it to the highest level on chess.com and tell me that one more time.
Yeah.
No, I'm not ready for that stuff.
But you've beaten people that are like level 1900, haven't you, Ethan?
Yeah, I have.
Yeah, that's impressive, dude. That's really cool. Yeah, chess is a great game. I think it teaches a lot about life, you know, like thinking ahead, like seeing, you know, what's next and whatnot. I really like that analogy of like forcing your opponent to do things. That's kind of cool.
But see, the thing is that it also applies real life stuff, like a pen
Mm-hmm.
or a skewer. Like they use actual thumbtacks for penning stuff and skewering. Well, that's
Skewering.
kind of
Yeah, skewering someone.
yeah, like
I don't want to get skewered, dude.
like
That would suck.
basically you're just gonna get like impaled by through some.
Oh
thumb
God, dude,
of your
no.
body.
That'd be bad.
I wonder how it feels like to be skewered, anyways.
I don't wonder about that.
That's dope.
No, it's not dope. Anyway.
But I hope y'all don't think me up crazy for this.
No, it's okay. It's okay. It's okay. Dark says, "What am I hearing, dude? It's okay." Destiny, how's college, dude?
I don't mean.
What's that?
I don't mean
It's
to
not
say.
bad, man. I'm doing really well in school. I have
Hell
all
yeah,
A's
dude.
in my nursing classes. So,
I saw you're doing well in your classes. That's great.
yeah, man. And I mean, like socially, it's a little bit of a challenge. Things
Yeah.
work very differently here than they do at home, and it's a
Oh,
little.
for sure.
Stuff's a little crazy with my roommate right now.
Yes, dude. Roommate drama is #1 drama. Like, I can't tell you how
Oh,
much
yeah,
roommate drama.
it's-
Yeah, you think you're cool with someone for like the first week or two, and then you start living with them, and you find out all their quirks, and you're like, I'm gonna murder this guy.
No, because I'm pretty sure I'm kind of easy to live with. Like, all
yes.
it's just,
Yeah.
and it's just my thing is my roommate has autism.
Oh, it's okay.
And
Everyone's autistic at this point,
yeah,
dude.
no, and that in itself is fine. It's just about the things that he can't handle
Sure.
that end up reflecting on our relationship.
I see.
And
Is it like the
and the
dishes, or
lack
like
of-
what? What can he not handle? Like, he can't
there's
handle
no
loud
dishes 'cause
noises?
We don't. No, it's not even that. It's like he hates the floor, and the floor hates him.
Oh, okay. The floor?
I mean, hate might be a
Like the-
strong word.
like the
there's a lot
ground?
of dislike there.
Wait, like the ground.
That's tough. Not gonna
The
lie.
other people on the floor.
Oh, the other people on the floor. Oh, I thought he like literally hated the ground. I was like, what? It's like, yeah, that's a little bit more than just autistic, dude. Okay. He doesn't get along with the other people on your dorm floor. I got you. That's
yeah,
okay.
no, and that has now we don't even get along. So it's just the whole thing is just
okay.
kind of nuts.
Maybe try to talk things out.
literally-
Try to talk things out.
we
Communication usually
tried.
helps.
But, like, he wants as little communication as humanly possible.
Oh well, that's not good.
Yeah, no, like he literally like I would be like, yo, is it chill if I turn off the light? And he would get genuinely annoyed and like groan out loud that I was even asking.
Oh, yeah. Okay. Well, that's not your fault.
And it's like, no, and it's not. So I've stopped asking. And one day, I was like, yo, you got any garbage bags? He's like, here, check through this bin. And so I look through the bin, and I'm like, I like take everything out of it, and I'm like, oh well, might as well just put. It's like, here, I'll show you.
Yeah, sure.
It's this little